Bring it to me. Bring it to me. So at this point in time, you should have written down your givens, which the givens are. Maddie, you want to show me? Oh, your stuff. Yeah, show it to me. At this point in time, you should have written down that it says oxidation state. We haven't used that term too much, but oxidation state just means a metal with a 2+ charge. Metal with a 2+ charge. And so that might give you some indication on how does that reaction form when you form your products. And I saw a couple of you guys got this far, and I went ahead and labeled that as excess, but I'll get to that in a second. You saw that you have a you saw that it gave you a mass of 0.3 or 0.033 grams of the metal. That's a fact that was given to you. You saw that you had 25 milliliter or 12.5 milliliters of the gas that was made. Well, at this point in time, I have written down my reaction, which is imperative, right? If you need to write down reaction, it's hard to do anything past that. So if you have your metal and it's reacting with sulfuric acid, and if you don't know sulfuric acid, you need to be reviewing your nomenclature for that. You see that it's going to have to be a single replacement reaction where the H gets booted out to the cold, and so you make a H gas, but it can't be just H, it has to be H2 diatomic gas. And how did I get this formula like it is with no subscripts? Jillian? Go ahead, Jillian.
They both have a 2 charge.
Right, so I told you the metal has a 2 charge because you wouldn't know that otherwise, and sulfate is a 2 charge crisscrossed down to 1, so that helps me balance my reaction, right? So what is it balanced? With a 1 to 1 to 1 to 1? All the way, right? So because there's 2 hydrogens and 2 hydrogens. And so I knew my gas was hydrogen gas. I knew my temperature at 296 Kelvin. Pressure, I took my millimeters of mercury to atmospheres. Let me just delete this little box. Okay? And then it says, what's the molar mass of the metal? So you have to organize your thoughts first. So when you say, what's the molar mass of the metal? Well, we know molar mass, the units for that, just like density has units. Density's units are what? If I were density, I heard centimeters cubed. That's not the only thing, right? What else? Grams per centimeter cubed, right? We call this density or grams per milliliter, but we call it density, right? So molar mass, we call molar mass, but it's really a combination of 2 units, which is what and what? Grams per mole. Okay, so over here, I'll write this over here. If you have your grams, check, that's our grams per metal. We have that given to us in the problem, 0.033. Our true question is to find the moles of the metal. So if that helps you organize your thoughts, I think you should write that down. So your question is, let's find the moles of the metal. But I don't have a lot of information about the metal. I have a lot of information about the what? The gas, right? I have the temperature of the gas, the milliliters of the gas, the pressure of the gas. I've got all this great information about the gas. So the 2 ideas that are always going to be incorporated in these problems is just basic stoichiometry according to the reaction and the ideal gas law. But it's your choice on which one you do first based on the information given. So what would you guys do first? The ideal gas law or stoichiometry? Why ideal gas law? Right. I mean, I don't have any. I have this mass of metal, but I don't even know the metal, so I can't really start with that, right? So by default, you have to start with the ideal gas law. So if you start with the ideal gas law, what are you going to have to solve for, knowing that this is what you have? You have V, T, and P. What would you be solving for? Moles of hydrogen, right? So the first step is probably to solve for N of hydrogen, and so this is like us talking about step by step what you'd be doing. Solve for moles of hydrogen from what? PV equals nRT, okay? After you get your moles of hydrogen, what could you do to get 2 moles of metal? How do you get your mole ratio? From your balanced chemical equation. You have a 1-to-1 mole ratio, and then you get your moles of metal, and then after you get your moles of metal, which I don't think there's anything here, okay? I really should have written this here. So I'm going to say NH2 from PV equals nRT, okay? And then you'll do your mole ratio to get to moles of metal, and then what? To get to molar mass. What was molar mass one more time? Grams over moles, and you have the grams, right? So you have this given to you right here. So you take your 0.033 grams, and you divide it by what? The moles that you just got, right? The moles you just got in part 2, you just divide by your number of moles of metal. And then Praneeth said it's close to who? You asked me what the identity of the metal was. Right, it's either zinc or copper, based on the number of sig figs. The accuracy of your numbers, if you round too much in between, you get a little different. But at the end, your molar mass of your metal is close to like 65 grams per mole. And if you look on the periodic table, or on yours, or on wherever they are here in the room, you'll see that copper and zinc are really close to 65 grams per mole. And this said this is a 2+ charge, right? Can copper form a 2+ charge? Yeah, copper 2 is blue. Remember that at all? Okay. And then zinc definitely forms a 2 because remember Z looks like a 2. So you'd be close to either one, but that was just based off our data that we collected. So that's what I'm going to stick with right now, because I think you guys are smart enough to plug in your data and you understand what I mean by mole ratio and moving on. Okay, the thumbs up that you can achieve that. If you wrote down your steps, do you feel like you could do that? Shaking your head or thumbs up or something. If not, you need to see me. But I'm writing down your processing steps because I think that would be insulting your intelligence if I had to do every single step for you. So number 3, what's number 3? Yeah. Number 3. So here's your first part, and this is the part that I saw a couple of errors. If you have a diatomic gas, you've got to write it diatomically. Again, who are the diatomic gases? The big 7. Okay, so is nitrogen in the big 7? Yes, please put a 2. Nitrogen, oxygen, fluorine, chlorine, bromine, iodine, and hydrogen. So do make sure you're putting your 2's there, because that's going to screw up your mole ratio if not. All right, so what did you guys see here to start with? How many grams of nitrogen are needed? So here's our question. To produce 48.6 liters of ammonia, so this is our volume, this is our temperature, this is our pressure. All right, so knowing that we are usually doing stoichiometry and ideal gas law, which of those could we start with on this problem? Why? Yeah, like I can look at that reaction, but I don't know anything to start with, right? So that's really my question. I'm going to have to do the tail end of this problem with stoichiometry. First part's going to be ideal gas law. So if you want to write down your steps would be, well, here's my givens right here. Oh, I have a marker. So my questions, grams, my volume, temperature, and pressure were given to me. So at this point, the only thing I have is information to do ideal gas law, IGL, ideal gas law, and you're finding what according to the givens that are given to you. N, okay, so find N of who? Of ammonia, right? And I did see most of you guys corrected that. On your problem set 12, you guys were saying ammonia was NH4. That's ammonium, right? And so ammonia is NH3. Just note that there is a difference there. So you'll find your N of moles of ammonia, and then that's what you have. You'll have basically this right here, right? So if the question is how many grams of nitrogen are existing or are given or used to react, then you're going to take your moles of this and then do what, Nick?
No.
Not related? Not to this? Okay, give me 1 second. What would I do if I have moles of ammonia? How would I get to my question of grams of nitrogen? Mole ratio, thank you. Okay, so then I'm just going to say this and then use mole ratio. And then what? Then grams per mole, or molar mass, however you want to think of it, like that. And that will get you to grams of nitrogen. But you just have to make sure that's N2, because if not, you'll say 14 grams versus 28 grams, and then we're still going to have a little bit of issue there. That number 3 was actually very nice. It was very easy. I think it was because there wasn't too much information to go like, okay, what do I start with? All right, number 5. Nick, you have a question?
Oh, yes. In the ideal gas law, what is R? Like, I know it, like, the actual formula is, but, like, what is it?
It's a constant that accounts, so, and a lot of our gases, they have relationships with each other, like we say direct or indirect. But there is actually a constant that relates them as well, but that's a very upper level concept. So there's like 5 constants with all the different gas laws we talked about, Boyle's, Charles's, combined, Avogadro's, and so forth. And so since everything is related, kind of within the ideal gas law, that R constant brings all those constants together. And so instead of me going, let's do this, let's derive our own R, everybody's always just told R. R is 0.0821 atmosphere liters per mole K. And so that's just a combination of factors that really are variables. Okay, Lindsay? probably because, I'm just gonna guesstimate here, either when you went to was your reaction balanced like this? Okay, probably because if you did it, your reaction, you didn't have a reaction, so you assumed it was 1-to-1 mole ratio just throughout because you didn't write anything down, and then you probably just did N for nitrogen instead of N2. So because you ignored the mole ratio and then the diatomic nature of it, the 2's and 2's work each other out. So you just happened to get it, but you wouldn't get much of your credit if I were grading it for your response. Just worked out because of the 2's. All right, number 5. Can I do number 5 now? Or number 2? We started number 2, right? We did number 2. Okay. Sorry, I did different things in different classes. So, okay. So, question: what volume of chlorine gas? 20 degrees Celsius. Pressure. It told us our mass of sodium was a given of grams. What is the theoretical mass of sodium that could be formed? So here's what I would think you guys would have done, and this might be solved in maybe 2 different ways. But if you have TP and V, you have that information. Can you do the ideal gas law? Do you have enough information for the ideal gas law?
Yes, you have.
Okay, so but at the very, very beginning, you don't, right? You're like, okay, well, I don't have enough information here, but let's see. So what are you saying to do with this, Jacob? Moles of what?
Sodium.
Okay, so you can go to moles of sodium. Can you plug sodium into the gas law? Okay, let's think, is sodium a gas or a metal? It's a metal. Can metals, solids go into gas laws? No, that's not appropriate because this is a gas law, right? So we have to convert our sodium to what? Well, no, I don't care about grams of sodium either. Who cares about sodium, guys? No, yeah. So we would definitely need to take our ratio and convert moles to chlorine. And remember, that's diatomic chlorine. I did see a couple errors on that. So let's see if this gets you where you need. So this would be my moles of chlorine gas. I have P and T. Can you guys solve for V that way? Can you guys solve for V given all that? Yes, you can definitely do. So step 1 is convert to moles of chlorine. Step 2 would then be what? Okay. So use the ideal gas law to solve. So plugging in everything else that you already have, solve for V of chlorine gas. So I'm just denoting what my identity is by just putting a little subscript down there. So I'm solving for V. Okay, so if you went to V, you already answered the first question. What volume of chlorine gas is blah, blah, blah. And then it says, what's the theoretical mass of chlorine that could be formed? So I posed a question down here, and I'll talk to you in a second about this. But if you've already done the job of taking your sodium mass to moles to chlorine, you've basically made them stoichiometrically equivalent, meaning you have exactly the amount of sodium to react with all the chlorine that you've just decided that you have. So if they're stoichiometrically equivalent, that means they technically are both the LR. They're both exactly going to run out exactly the same time because you made them equivalent through this through this stoichiometry right here. So it doesn't really matter who you use. You can use your moles of chlorine or your initial mass of sodium, and you can take it to the final product. You can do either one. So at this point in time, what do you guys want to do? If you're going to go just simply to mass of sodium chloride. Do you care who you start with? Either this one or this one? It doesn't matter because you made them equivalent, so they're both the LR, they both run out at the same time. Either one will work for you. So most of you guys probably started with your original. You may have taken your 4.6 grams of sodium to moles, just like you did here, and then you could have gone all the way over here to sodium chloride. Yeah.
Instead of converting from sodium to NaCl, I just got, I used the mole of sodium and I still got the right things.
Yeah. Is this the one, is this 2.6 on your paper?
No.
This is the one, yeah. So this, I think, in terms of correcting something from the past, this is an old copy. I think I copied the newest copy of my lecture notes for you guys. So this is, I'll tell you the answer is moles of chlorine, which would be N of chlorine gas would be 0.1 moles. when you converted, and then, is that what you guys got? Okay, and then volume when you plugged into your ideal gas law, volume of chlorine gas. Sorry, I meant to show you guys that yesterday. I was like, let me double check my answers, but we moved pretty, we were moving through the other examples versus this one. So when you plug into your ideal gas law, I think you guys should have gone 2.6. Sorry about that misinformation. And then as you went through to your grams of sodium using stoichiometry, mass of sodium chloride, you should have gotten 11.69. Okay, cool. 11.69. So this should be what's on the bottom of your answer key. Well, not all the information likely, but that's what you should have done. Yeah.
If you got something different.
Did you? Well, let's talk about. Did you take?
I think it was the curiosity.
Oh, well, that's not gonna. Oh, if it's really close.
Wrong or not.
Let's say it's really close. So let's take 4.60 grams of sodium. 1 mole of sodium weighs 22.99. And then you would take your sodium. What was the ratio between sodium and sodium chloride? 2 to 2. Okay. 2 moles of sodium chloride are formed for every 2 moles of sodium utilized in that reaction. And then your final step would be to take your moles of sodium chloride to actual grams. And that's our molar mass that we consistently use, 55.85. And as long as that matches mostly, you should get something very close to that.
Whoa, how did you, why are you using 4.60?
Because that was like I said, you could have started with your grams of sodium given to you in this question at the very, 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 very beginning, or you could have started with your moles of chlorine gas you found at first. Either way will get you the same spot.
I'm kind of confused, but.
So, did I explain your question? Okay, we'll talk a bit more then. We'll talk. So I wanted to give you guys a chance to at least look at it, walk through the demystifying of how do you start. But if I've given you some guidance on how to start, I want you guys plug in your values and finish those. After so. Okay? And here's my goal. If you need to finalize your group for the science in the box, that's something you're going to do first. But I also want to go ahead and give you guys an option because you guys will have a benchmark the week after Thanksgiving. It won't be the first day. It is not the first day, but it'll be that week. Benchmark's only 20 questions, but it's a cumulative review of units 1 until now. But we've kind of been embedding some review, which is nice. The only thing we haven't really reviewed a whole lot is like electron configurations. You know, that kind of like subatomic particles. But we've included some reactions, nomenclature, stoichiometry. We've got gases right now, so I think we've done a very good job. Maybe like some of the models and stuff we don't talk about, like let's talk about Thomson's plum pudding model. We're not just like randomly saying that in the middle of the gas law problem. So in this case, that's what I want you guys to do, is I want you to have some time for review. You will start with the scavenger hunt in my room. I'll show you where it is. If you want to pull out your phones, look at this link. And you guys, I would recommend you work in your science in a box groups. That way, whenever you guys are like, okay, I think we've reviewed enough, we can go back in Miss Inlo's room and work on science in a box. Or if you want to start with that right now and then go, that's fine. But I would guess it would be best to go ahead and decide on a couple things for your groups. So it's only about 20 questions, like I said, cumulative. The scavenger hunt starts in my room. It also is in Mr. Maycumber's room and Mr. Metzger's room. But there are different things in different rooms. So when you pull up this link, you'll see, give me a thumbs up when you get to that link. I'm going to put my little thing here. When you pull up that link, you'll see there's 10 questions for Mr. Maycumber and Mr. Metzger's room. And then 20 questions for Inlo's room, because I'm an overachiever and I wanted to make sure you guys have everything you could possibly need. And of course you can choose whatever you want to do. I am using the scavenger hunt as just a classwork grade, but if I feel like you've done an excellent job, I'll give you extra credit. Okay, so that's up to you guys to work in a group of 3 or 4 very efficiently. And you will need a piece of paper. Can I go away from this screen? Okay, I'll wait there. Okay, I'll wait there. So note that the rest of the time is for two things, scavenger hunt and science in the box. You guys have your instructions from last night online for science in the box. But please, please, please make sure you talk to me because I just need that little snip of here's our group, here's our topic, here's our grade level, and here's what we think we're gonna need. If you don't have all your procedures done, I totally understand, but I need new materials because I gotta buy this, right? So I need to probably buy that over the holidays. But there's some things that I want you guys to make some decisions on today. So if you're good, then you can go down, scroll down to the section that says influence room, and that's where you're gonna start because I told them I would try to respect them and let you guys do my stuff in my room first. But I will go back to the screen in a second. So the questions are they're entertaining, but find the white balloon. Has anybody found the white balloon yet? Okay, not everybody start number 1, please. Please start, there's 20 questions to choose from. But you need to get in your groups of 3 or 4, okay? Does anyone have any questions right now? Get started, guys, get started.
Found it. Sorry.
Okay, I'll look at this in a second.